Bismillahirrahmanirrahim. Assalamu alaikum everyone. Welcome to the sequential control part 8. Here I will be solving this problem. So let A be the clamping cylinder. So suppose this cylinder is A, clamping cylinder, and B is the stamping cylinder as shown in the figure. So this cylinder is B. First cylinder A extends and brings under stamping station where cylinder B is located. Cylinder B then extends and stamps the job. Cylinder A can return back only cylinder B has fully retracted. Okay, so what will happen? This cylinder A, it will extend, and this is the job. Okay, this job will move here. When the job is in this position, cylinder B then extends, and when this extends, this will stamp a logo or something on this job. Then immediately it retracts. Then cylinder A retracts. So from this, we know that the sequence will be A plus, B plus, B minus, A minus. So you might think that this is a simple sequential problem like A plus, B plus, A minus, B minus. But I assure you that it can be solved in the normal way. So first, let me show you the timing diagram and a step diagram of this circuit. So these are the step and timing diagram. First A plus, then B plus, B minus, then A minus. In fourth step, it will happen, and T1 to T5, the timing diagram, this process will finish. So I hope you are familiar with this circuit. This is covered in this video, and there will be a I button here. Please go check that out before starting here. And I want to mention you that this is a continuous operation. So after A minus, again A plus will happen. The sequence will be A plus, B minus, A minus, then again A plus, B plus, and so on. First, the operator will push this button, and there will be a signal here, and this side will actuate. So a signal will go here, but I have to fulfill a second condition. So what will it sense? So before A plus, I can see A minus is there. I can write A0. Okay, signal is going there, and A0, initially it is in A0 position. Then both conditions are fulfilled. Now flow will go here. This side actuates, flow will go here, and A plus occurs. Okay, A plus is completed. Now after A plus, I can see I need B plus. So this is B plus, here A1. Okay, so this 3 by 2 will sense A1. So after occurring A1, this actuates, a flow will go here. This side actuates, flow will go here, and B1 occurs. Now immediately I need B minus to happen. I can see after B plus there is B minus. B minus is here. So this lever plunger will sense B1 obviously. When it senses B1, a flow will go here. But there is a problem, because if you remember, the A cylinder is still in the A1 position, and A1 is activated, and due to that this 3 by 2 DCV is still activated. So its flow is still going to this 5 by 2 DCV. So although I'm giving a flow to this side, this 5 by 2 valve won't get to this side because it is already in the left position. This is a conflict. Say somehow I managed to terminate this signal, then my problem is solved, right? Yeah, definitely. So if there is no signal and there is signal in the right side, the right side will actuate, a flow will go here, and from B1, B0 will achieve. So I have A1, B1, B0 all done. Now I need A minus, and A minus is here. A minus will sense B0. I can write B0 here, and this B cylinder is in retracted position. So obviously this side will get actuate, but is there any signal here? This A cylinder is in A1 position. So definitely there is no signal in the left side. So I can safely give signal to the right side, and right side will actuate. and flow will go here, and from A1 A0 will achieve. So I completed A1 B1 B0 A0. Next again A1 will happen. So let's see that. So this 3 by 2 DCB will sense A0. So is this A cylinder is in A0 position? Of course, it's in A0 position. So a signal will go here. But one other thing, is there any signal in the right side? That's the thing. B cylinder is in B0 position. So obviously there is a signal in the right side. Although I am giving a signal to the left side, the 5 by 2 DCB won't budge to the left side. It will remain in the right side. So there is a conflict. But if I somehow terminate this signal, will my problem be solved? Obviously, there will be a signal, then this 5 by 2 will move to the left side and a plus will happen. I can see that these two 3 by 2 DCB is creating a problem. In natural means this problem can't be solved. But if I configure this lever plunger to ideal roller, then I can solve this problem. First, let me tell you, this ideal return roller will be a very specific location between this A0 to A1. So let me go through that. Operator pushing this button, this side actuates, signal will go here, then this side actuates, A plus. Okay, done. Now for this B plus, this have to be a ideal return roller. So if I put this ideal return roller to like this position, and if I change this to AX extending, then there will be a solution. So let me explain this to you. When a cylinder is extending, okay, so this is extending, right? At this AX position, AX is very close to the extreme extended position. Remember that. So this AX position is very close to A1 position. So when this rod trips this ideal return roller, then this will activate. Activate, then a signal will go here and the left side will get activated. A signal will go here, then B1 is achieved. But AX immediately deactivated. So there is no further signal here. Now, when the B cylinder moves to this extreme position B1, then this lever plunger will activated and a signal will move here. Remember that there is no signal in the right side. So a signal will go here and B0 position is achieved. But there is a problem. This 3 by 2 DCB needs to be changed with the ideal return roller. So I can put this ideal return roller to this side. Suppose this is Bx position and I can write here Bx retracting. Okay, so when B cylinder moves to B1 and then again moves to Bx position in retracting position, then Bx sends the retracting cylinder. It immediately activates, Bx activates, a signal will go here and from A1 the cylinder will move to A0. While moving to A0, this AX position is not activated. Okay, and after appearing to A0, 3 by 2 DCB will activate it and again flow will go here and A1 position will be achieved again. So this is the overall solution. Basically, I need to put two ideal return roller in these two position. In one position, this roller should be closer to A1 and the other ideal return roller should be closer to B0. So with this, we can solve this problem. So let me show you in the simulation. Okay, so this is the simulation and I already drawed a picture for your understanding. So it is for the A cylinder, this is A rod and this ideal return roller is positioned to closer to A1. Here AX and A1 is in close position and BX and B0 is in close position. So let me also show you the range of this AX and BX. So you can see A0 at 0 millimeter, AX is 95 millimeter and A1 is 100 millimeter and the rod length is 100 millimeter. And if you want to see B, so B0 in 0 millimeter, BX is 5 millimeter and B1 is 100 millimeter. And I already explained all of this to you. And if you want to see where is the ideal return roller, so this is in the mechanically operated part, and you can see this is roller lever when extended, roller lever when retracted. So let's start this operation. And this left is the on switch, right is the off switch. Okay, start. Pushing the on switch. Let me show you again. See? So A plus, B plus, B minus, and then A minus. And it is happening continuously. So if you want to see what will happen if I used normal lever plunger instead of this ideal return roller, then you can see what is the conflict there. Okay, so here you can see the conventional way. I'm using just normal lever plunger. Now let's simulate this. Okay, you see there is already B0 activated in this side. So if I push the on button, then you can see for this A0, there is also a signal here. So this is a signal conflict. So it was conflict on this side. We replaced this 3x2 DCB with a ideal return roller. So if somehow we negate this signal, what will happen? Let's see. See, when I negated this, this A1 happens. Due to A1, this B1 also happens. But there is again B1 signal here. This is another conflict. So if I cancel out this signal, then see again will be a conflict at B0. So to remove this signal conflict, we used this ideal return roller. This is the overall solution. If you have any kind of problem understanding this, please write in the comment. I will definitely give you an answer. So that's all. Allah Hafiz.